All right, what we're going to do here is take a look at our math zone, Math 1108 College Math course workbook. And this will be similar for the spring of 2017. You're going to put your name, your course number, instructor. Now the first page inside the cover, of course, is a series of formulas that we'll be using. Some of the skills dealing with fractions and exponents. These are for graphs, and we'll be referencing this from time to time. Functions of graphs, this is for the circle and vertex, quadratic formula, the discriminant, some values, and then when we deal later with exponential and logarithmic functions, properties of logs, and then toward the end of the course, sets and probability. So we just continue paging. Now you'll have your particular pacing guide. This is the one for this book, and gives you those dates. And they ask to do this mindset assessment profile where you rate yourself and then eventually come up with a mindset score. And a few other things. All right, those are all things that we get ready for. And now what we're going to do is, as you see this, you can solve this equation. We'll always give you a chance first, and then I will go through the steps. And again, this is evaluated for grade. So you want to have some nice, neat, and orderly work here to support your answers. So, using skills we went over in our earlier course, how do you isolate the x? This is an equation. Well, we're going to subtract 10 from both sides, or just transpose that. On this side, it becomes a negative 10. So we then get 21. And to isolate the x, we're going to divide both sides by 7. And we get x equals 3. So the equation we can use, this is our next step, and then our solution. Now for number 2, again, you might want to get rid of the decimals first by multiplying each term, and there are 4 terms altogether, by 10. So the shortcut is just move the decimal place over one place. And then we have to add a 0 here and move the decimal one place. So we'll give you a moment. Okay, so we've rewritten this. 5x minus 2 equals 4x plus 40. So again, we want to have all the x's on one side, all the numbers on the other. So we're just going to subtract 4x from this side and this side, or transpose that 4x. On this side it becomes a negative 4x, leaves us with an x. We're going to move this negative 2 to the other side, or add 2. So this was an easy one. Now notice we left out steps here, but in an advanced course you are allowed to do that. If you want to include more steps, of course, that would be encouraged. So let's get started on number 3. We'll pause. But the key to number 3 is to clear parentheses. That's one of the main things we do. So we get 4a minus 13 equals 2a plus, as we distribute that, 2 plus 16a plus 2. Now we collect like terms. 4a minus 13. Now we have a 2a and a 16a will give us an 18a. We have a 2 and a 2, which will give us a 4. Now we're going to get all of the a's to one side. And we could use this side too. I like to keep my variable positive, so I'm going to subtract 4a there, subtract 4a there, and get 14a. I'm going to subtract 4 there, subtract 4 there, that gives me a negative now, 17. And now I'm going to divide both sides by 14. And I get a equals a negative 17/14. And my 4 didn't come out too well, but it's a little better now. Now you might say, well, where can I put that negative sign? Well, I could put it up by the 17, but actually the best place to put it is by the division bar. All right, let's see what you get as you do number 4. First thing I'm going to do, clear parentheses, and then combine like terms. So that's 3k minus 6 minus 6 equals 3k. Now, when you have a negative in front of a parenthesis, we remove the parenthesis and just change the signs. So this becomes a 2k, a negative 2k, and this becomes a positive 1. So again, next step, collect like terms. 3k minus 12 equals k. 3k minus 2k is k plus 1. And I want my k's to be positive, so I'll subtract a k, or transpose it, becomes a negative k. Bring this over to the other side as a positive 12. 12 plus 1 is 13. Now I'm going to divide both sides by 2. I get k is 13 halves. Now the answers to all of these are on page 25 of your booklet, which is a good deal. All right, let's look at example 5 now and see what techniques can we use to solve an equation when they have fractions. Well, let's identify our terms here. This is one term. Now remember, the 5 is the number of the example, so we want to be sure we don't get that messed up. This is one term, a negative 3. The 4 is one term. And this is all one term. So we have 4 terms, and the rule is to get rid of fractions, we want to multiply each term by the lowest common denominator, which happens to be 20. So let's do that. Multiply this by 20. Multiply this term by 20. This one by 20. And this one by 20. Now, some authors, they just put a parenthesis out here and then multiply everything by 20 that way. I like it this way. So these cancel out. This, nothing cancels out there, nothing there. Here, 4 goes into there once. Here, 4 goes into there 5 times. Okay, so now we rewrite it. 9y minus 60 equals 80 minus, no, it's a minus 5 times 5y, a minus 25y. Now again, we like to keep our variables positive, so I'm going to take this to the other side as a positive 25. So I now get 34y. I'm going to bring this to the other side, and it becomes a positive 60, and 80 is 140. Now I'm going to divide both sides by 34. And I get y equals and we can take a 2 out of each one, so 70 over 17. 70 17ths. Now as we go on to other pages, we're going to take a look right here and see what can we get. Well, we're going to distribute to get the x out of there. So this is 4a plus 4x equals b minus a plus 2x. So we've gotten the x out of the parentheses, the grouping symbol. Now we want to get all the x's over to one side, so I'm going to subtract 2x, or transpose it, and I'm left with a 2x on this side. I want to get the 4a on the other side, so this will be a b minus, now when I bring this 4a over to this side, it becomes a negative 4a, and this one negative a gives me a total of a negative 5a. Now to solve for x, I divide by whatever the numerical coefficient of the x is, and everything on this side. Here these cancel out, and I get x equals this, which is our answer. All right, we'll give you a moment to work example 2. Again, we want to solve for x. So 8b minus 8x equals 6b plus ax. Now we want to get all the x's on one side, everything else on the other. So I want to get this out of this side, so I'm going to subtract 6b. Subtract 6b, I get 2b on this side. I'm going to bring my negative 8x to this side, so I have ax. On this side it becomes a plus 8x. Now I have an x in two terms. I'm going to do the opposite of the distribution. I have to factor out an x, and I get a plus 8. Factoring the x out of each term equals 2b. And now I'm going to divide what I don't want, both sides, by a plus 8. And these just cancel out, and I get x equals 2b over a plus 8. Now in the answer key they say 8 plus a, that's fine. This way is fine too. Alright, we want to solve for the letter n. Well, when it's something times n, these are both factors, we can just divide by the letter we don't want, which is a j here. So we get n, I could write it on this side, equals b over j. Now this looks like a capital, and when you put it in Math Lab, you have to use a capital. So I made it a capital. Now in looking at number 4, we're wondering what technique can we use to solve for the letter R? It's inside a parenthesis, but this has a fraction. This is all one term, and again, this is one term. Multiply both sides by a 2, so this becomes a 2b on this side. Multiply this side by 2, the 2's cancel out, and we want to get the R outside of the parenthesis. So this is HR plus HC. And again, we want to solve for the R. So we're going to bring this term over to the other side. So we get 2b. On the other side, this term is a negative HC equals HR, and we want to isolate the R, so we're going to divide both sides by H. And this division bar also serves as a grouping symbol. All right, what are you going to do first here in number 5? Multiply both sides by 2? Excellent. So 2g, multiply that side by 2, this side. So here the 2's cancel out and get this outside the parentheses, so this would be 3p minus 93. Transpose this now to the other side, and we get 2g minus 93 equals 3p. And to get the p alone, we divide both sides by 3. So p equals this. Now, where these answers are acceptable, at least to me, they're not what the book has. What the book did is they did some division here. And divided this by H, divided this by H, like so, and divided this by 3, and divided this by 3. Okay, again, this is okay. So this would then equal H, or I should say R, this R equals 2b over H. But now here the b's cancel out, and you get minus C. Aha. That's a Z. And then here, this is P equals 2/3 G. And then now the 3 will go into there, of course, 31 times. And these are the answers they have in the booklet. Although what I had here originally was okay. They just wanted more simplification. And you might say, well, how do I know what to put? Well, as you do your math lab, they will tell you what they want as the acceptable answers. Now, for example 1, on this page, we're looking at our equations, but they're absolute signs. And you might say, well, what is the strategy for doing that? Little flashback there. And the strategy is this. Rewrite the equation without the absolute sign. And then write the word or, Now, rewrite the absolute part here without the absolute signs. But now instead of saying a positive 4, we say it could have equaled a negative 4, because the absolute indicates it could have been a negative value as well. So this is how we do these. We take away the absolute signs and just write it the way it is. Or take away the absolute signs and then the opposite to what's there. Okay? And then we solve each one. So we get 2x now. Bring this over, becomes a positive 1. Divide both sides by 2. X equals 5/2. Or, again, bring this over as a positive 1. This now becomes a negative 3. And you get x, after you divide both sides by 2, a negative 3/2. And that's as easy as it is. All right, we'll give you a shot now at number 2. Again, without the absolute value signs, and then make this a negative 35. So, pretty straightforward here. Y is 1. Y is a negative 13. And again, if you have any questions, be sure to bring them into Math Zone so we can check them out. All right, let's do number 3. Give you a moment. Checking your work. Again, we're looking for neatness and orderliness. And the answers are on page 25. All right, again, setting this up the same way. 9 over x minus 4 equals 12. Or 9 over x minus 4 equals a negative 12. And the technique we can use here is we can just cross multiply here. This will be 12x minus 48 equals 9. And then we'll transpose that. This will become a positive 57. X is, after you divide both sides by 12, 57 twelfths here. Or this is going to be a negative 12x, positive 48 equals 9. So as we transpose this now, this becomes here a negative 39 divided by a negative 12. This then becomes a positive 39 twelfths. And these are our answers. Giving you a chance to do this one and setting it up properly. So looking at these then, again, write it without the absolute signs. Write it without the absolute signs, but take this value and its opposite, negative 11, and it's over 1, so you can cross multiply. We get this, and then solve for x. So this is one answer. These are both negative, so that ends up being positive. Okay, and again, you can check the answers on page 25.